Hey guys, my name is Greg Hogg. SQL is probably the most important skill for a data scientist to have. So in one video, I'm going to go over the complete basics, so from absolutely nothing all the way up until not mastering SQL, but until you can do a really good job in the majority of data science interviews. So here's that video, subscribe if you haven't, and enjoy. As data scientists, we use SQL to retrieve data that's stored in relational databases. Here's one such relational database, which is made up of many tables. So you can see here we have customers, categories, employees, order details, and so on. So all of these tables have some sort of name where it stores stuff that, it's just data. So in the customers data set, we have their ID, their name, their contact name, their address, and so on. So we have stuff about customers. In the categories table, we have here, it's like drinks and food. So category is one, beverages is a category. We have a description of that category. Another category is condiments, I have a description of that. Okay, so you can see it's some sort of store where we're separating our different ideas into tables. We have, say, customers, order details, categories, employees, and so on, each in a table. The first thing that anyone would teach you about SQL is to get all the data from one table. And for a long time, we're only going to work with one table because most of the stuff you do is with one, and then it's just a bit of an extension to work with multiple tables. So the first thing you would do is select star or asterisk from, and it has to be in this order too, select star from whatever table you want, say customers, and that gets, and you put a semicolon after it, you get all the data from the customers table. So if I run that SQL, it'll get all of that data. And what we mean by all the data is that all of the rows and all of the columns. Okay, so here is actually where I specified what columns I wanted. If I only wanted some of the columns, because star means all of them, if I only wanted some of them, maybe I only wanted the names of people and their addresses. So that shows where everybody lives and what their name is. So I could say select contact name, comma, address, making sure to spell these things right. If I run that, I get all of the rows still, and I get the two columns, contact name and address. Note that if I typed it accidentally like select like this is actually going to work just fine. If I instead wrote contact name with a T, capital T here, that works just fine. As in, SQL is never case sensitive. It doesn't matter if it's in these names here or whatever. Lowercase and uppercase are exactly the same thing. Note that there's actually many flavors or different types of SQL, and there might be some scenarios when it is case sensitive and some other rules that, it's just differences between them. But the point is that you just do whatever in your SQL scenario in whatever setup you have, and the interviewer, if you're in an interview, they really don't care if you're off by these tiny, tiny little things. Nobody actually cares. So here I went back just to select star from customers. I have all the data in the customers table. Note that there's a couple different data types that are very common. Here we actually only see strings, which is pretty much just words or random information that you'd have as text. In the orders table I will go to, so select star from orders, they're putting in the brackets, not really necessary here. We have other types of data as well. We have order date. So when did this particular order ID, so here's just an identifier, you're going to see this very commonly. We want to be able to identify rows, and so to do that we have some specific ID. So for that ID, it was on this was the date of order, and this is going to be an actual date type in SQL. Technically we have some integers here as well, except I don't really like to think of these as anything other than strings because these are just kind of ID fields. I don't know what the type actually is here, it doesn't show us. We could look at that later, but let's look at actual numbers. So products has some real values here. So we have a product ID, its name, which is a string, some IDs, a string as well as unit, and then we have a price. Okay, so here, this isn't an integer, this is a floating point value or a decimal value where we have an actual number here, which is a lot of the time in SQL, you're going to be working with aggregation. getting averages or the maximum or the minimum, which works for a lot of different data types. It even works for date types a lot of the time. You can ask the minimum date, which is basically chronologically the first, or the max date chronologically the last, and say the average date. That doesn't really make sense, but the average price here, that makes a lot of sense. So now let's work with very commonly some operations that you would do on any data set. Okay, so now we've talked about the data in general, but let's go back to the customer's data set and just do common SQL stuff that anyone would do. But working with the customer data set, let's look what we can do. Say, for example, we wanted to limit the rows that we get. A lot of the time in SQL, you only want to get specific rows. Sometimes you might only want to get even one row if you're looking up someone by their name, for example. So here we are, we have the customer names. So you would probably want to be able to answer the question, get me all of the data, or at least some of the data, you can specify what columns, but for example, get me all of the data regarding the person with the name of Alfred's Futterkist. Interesting name? Okay. You can do this with what we call the where clause. Where specifies what rows we return. So we select star from customers, except that's just unfiltered, that's everything. Except where, this is specifying only the rows, so only the rows where the contact name, actually let's go customer name, where customer name is equal to string, so quotes here like normal programming language, Alfred's Futterkist, I don't know how to spell it, sorry for butchering that, but if I do that, and I put it in strings, I run the SQL, and I get all of the columns. So notice I get every column. That's because I selected star. And I do that from the customers table, where the customer name is equal to that thing in string. So it ran over and over again and said, hey, all of this stuff in here, is your name equal to this? Well, the only match it got was this particular row, so this is the result that we get. Sometimes it can be tough to get an exact match, as in there's times when you would want to input exactly something like Germany, except maybe, you're a human being. You might only know, say, the first few letters of their first name. Say like, okay, someone asks you, get everything about the people like Alf. Okay, I don't remember their full name, Alfred's blah, blah, blah. Get me everything you know about Alf something. So we can do that where country, except not country, we would change that to customer name. So where customer name is like, not Germany, that's possible, but that would probably return no results. Okay, so where customer name is instead like Alf, and this may or may get more than one person. It actually gets nobody. And the reason for that is because if I'm saying it just like this is identical to saying it is actually equal to Alf. Like allows us to use these other different characters that specify kind of a pattern matching type thing. So if I do Alf with a percentage sign, that says, okay, it has the first thing to be A, then L, then F, and then whatever afterwards, I don't care. So it would match Alfred, it would match Alfred, whatever it is, it would get those results. It turns out that only Alfred's is the one that comes up. But we can see how this works a little bit better, where if I have A, well, that's saying everyone that starts with the letter A. Okay? And if I do this as lowercase, so instead like A, well, it returns the same things. Okay, it got those as well. So again, this pattern matching was also not case sensitive. It would be a waste of your time to show you all the different things you can do with this or other operations, but I'm just trying to show you the different techniques so that you can look up what you need to. I'll show you one more thing just so you get used to the idea. If we instead of A%, you could do %A, what do you think that would do? Well, % before meant anything, so it still means anything now, so it means anything, and then it has to end with an A. So this is all the people whose names end with A. I'm moving on to the orders table again so that we can do something similar but with dates. So instead of looking at what rows based off of like an exact match or like a pattern match, we're going to look at the idea of something in some interval. So with dates, it's, chronological time. It's not always just one day then the next day. That's what we have here. Sometimes we have times as well. So this day and this time, you could ask between the same day on different times, except we're going to ask questions right now of, say, between different days or between different months or years. So a natural question to ask is, say, if we're looking at 1996 stuff, let's try and get everything that happened between 1996 and 1997, for example. Okay, where I'll show you that we have all of that data there. So if I do select star from orders, where order date is between, okay, so where order date between, we have, if you put it in quotes, 1996 and 1997. So I'm trying to get all the stuff between 96, so including 96 and 97, all of those different rows. This returns no result, okay? And the reason for that is because I need to write the pattern of the date here. So if I do -XX -XX, and if I do that here, then that is going to return the result of all the stuff except only in 1997. We didn't get any stuff, any rows in 1996. And that is because when you're doing this with dates, you can actually use between with other types of data as well. But if you're doing with dates, then what happens is that the second thing here is inclusive, meaning we include it, and the first thing here is exclusive, we don't include it. So to fix that, we would just do 1995, and so then it wouldn't include the 95, but it would include 96 and 97. So we have all the stuff in 96, and it's a big long list, but we'd have the 97 stuff as well. So believe it or not, that is what a lot of data scientists do day to day. Obviously, you do a lot more complicated than that stuff, except a lot of the time you're just looking up stuff, between here and here based off of some type of string value so that you get information that you want from some particular table. This is actually pretty good so far. Now, of course, we know that data scientists love numbers. So a lot of that stuff does happen in SQL sometimes. Say, for example, we wanted to compute the average of something. Well, we could do that with they call it average, okay? So AVG. So if we do this, if we select, let's show now just so price. I jumped over to the products table so that we have some numerical values here. So if I select price here, I get all the prices. Now, if I select average, okay, and I'm putting it in caps just for fun. If I select average AVG of price, then that computes the average price, as in for all of those rows that it included in this calculation, which was everything, we'll filter it after, but it summed them all up, divided by how many there were. How many actually were there? Well, we can answer that question too. If instead we counted all the price, well, there's 77. Hold up. Why do I have to do price? This is the same. It's counting rows, okay? So if I limit it to a column, it doesn't really matter here if I'm using count. I'm just saying how many rows do I have? Well, I could say count of star or whatever other columns I have. I'm just counting the rows. There's a couple other of these operations that are probably unsurprising, and I think I already mentioned, which is select the min. So if I was to get the price column and then I got the minimum of the price, then that gets the min price. And notice that it kind of actually calls this thing min price, which will come up later. What we could do, which I'll show you right now, is aliasing, which is basically saying, call this something else. So select min price. Well, that's kind of a column name now. It's a column. So we can select min price as, we'll call it min price from products. And then that aliases it right there, which is nice for reading it. It's going to be a lot more important later when we start to actually use multiple tables. We're going to need to know what these things are called. Again, believe it or not, we just covered something called aggregation, which is really important for data scientists. It's just computing averages or counts or maxes or mins. I didn't do max, but we could do max. This is something that we do every single day, just calculating different aggregations. Let's take a look at the data here so that we can introduce a new, very important idea. So this is the idea of grouping. Notice that here we have basically groups. So we have category ID. Well, this row, this product name was in this category, and we saw earlier what that meant. Later we'll join these tables so that we combine the information. Right now let's just look at it. So if we have a category ID of 1, that means we're really referring to the beverages category. If we're referring to category 2, it means we're condiments, and so on. Each distinct category ID has some distinct category name. It means something. So if we go to the products table, every time we see a row that we look at its supplier ID, or sorry, its category ID, we say, oh, okay, you belong to this category, you belong to the same category. So that means we have different groups. Each group is a category, or each category is a group, really. So if we group by this category, well, we can do this even just by writing select star from products, group by category ID. Watch what happens. We have them grouped, okay? And some SQL versions might have failed in this because we didn't specify something which I'll talk about later. But for now, we see that we have one entry of each of these things. Really what it did is grab the first entry from each of the categories that it saw. So it got Chase, there's other groups, there's other members of this category 1 group, other products, but it took the first one here, and we have some price here. So if we know, we understand the idea of grouping, well, if we basically, you can picture it in your mind as, and actually let me show you one command just so that this makes sense, is select star from products, sort by, okay? Order by category ID. Okay, so we have all of the ones here. Here's this group, all the twos, and by default it's going in order. So that's, I didn't even plan on showing that one, but there you go. There's sorting. So if you can picture it as every member of this group, then every member of this group, and it's basically partitioned for each group, then we have a group price. Okay, so a group average price. We have a group minimum price. The group minimum price is whatever for all of these category 1 IDs. So for all of these, it is the minimum value. It is, I believe, 4.5 here. For category 2, we have all of these ones. These form some price group. We have all these different prices in the group, and the minimum price would be, I think it's that 10 value there. So if we do select star from products, not order by category ID, but group by category ID, and then not star, but average, and that can be lowercase, average price. So if we do average price and we group by the category ID, well, that says a bunch of different average prices, and it is for each group. Except you'll notice when you start to do this with grouping, it doesn't make any sense until you give it at least the group as well. So if we have select category ID and their average price grouped by the category ID, then we can see for each category what is the average price. This, again, believe it or not, is starting to get to some of the really useful stuff in data science, is grouping and performing an aggregation per group. You could do this for an average price. I explained it before as the minimum price, but there you go. If we do the minimum price, then I was right, it was 4.5 for them, 10 for them. Extremely useful stuff. You can do all of these, at least most of these aggregation functions in the group. Okay, so before we get into working with multiple tables, which is coming right up, for now we're going to do just a couple tricks that are going to come in handy. So we already saw, I'm sticking with select star from customers right now. So we already saw sorting just a little bit. We saw order by some column. So if I say order by customer name, then by default that's going to arrange them. If it's a string, it's going to be alphabetically, and if it's a number, it's going to do it, numerically, whatever makes sense. And so here it's ascending. So A, you can think of it as the bottom, and say Z would be the end. It's probably not, but we'll say Z is the end. We can change this to order by customer name ascending, which does exactly the same thing. If I write ASC, it's by default ascending, so that does nothing. If you wanted it the other way, you could write descending like that. Okay, so now it starts at the last letter, which I guess is W, and works backwards. We could also do something called limit. So if I wanted to limit 1, so limit some number, that arranges the SQL table. So it does everything before this, and then it says, okay, actually only give me the first one. Or if I only want the top 5, then I could do this. So something very common if you're working with other languages like, pandas, for example, or Python or R pandas, then you could do just like head or tail. So that's basically what limit does, is combined with order by and limit, you could get like the first 5, the last 5, the first 1, the last 10, whatever. As an introduction to working with multiple tables, we're going to look at the keyword in. So get rid of this, we can use select star from customers, except if we write where, say, country, okay, so where the country column, where this value is in some list, and we do it as like a Python tuple basically. It's round brackets, so we do this, and then we'll say, okay, where it's in the list of Poland. And so if we had just that, then it's the same as saying where country is equal to Poland, so that's only this one. And we could also have, say, Germany, so just Germany, and that is, remember before we got multiple results there, except we could put multiple things, and here's the point. So we could do Poland and Germany. Okay, so now we get all the Germany ones and the Poland one as well, and it might sort them alphabetically. The order is not really that important here. So now I'm looking at just the customers table. We have all the information here. So they call it a relational database because this data and tables, they're related to each other. So this customer ID here, which turns out to be what we call the primary key, that just means a column or set of columns that uniquely identifies a row. Therefore, you'll never have duplicates of them in the same table. As in 1 here, you'll never see another ID with another row with the ID of 1. Or instead, we could have chosen a primary key, which is, say, the name, the customer name with the address, because you're never going to see the same name and address combination. That just doesn't make sense. So we want ways to identify or uniquely identify a row. So that's why we choose some primary key there. And we generally make it an ID to make it easiest. So this ID here, this primary key customer ID, we're going to see it elsewhere. If we look at the orders table, we have, for each order, there is some associated customer ID. So there might be duplicates here. There might be rows, multiple rows with the same customer ID because, customers might make multiple orders. We're not going to have multiple of the exact same customer, but we might have the same customer making multiple orders. So here, we might want to ask questions like, okay, get me the information about employees, except only something based off of this table. So get me the information about the employees, as in all of the stuff that's in the employee table, all the columns, except for only the employees where, say, their order ID is something in particular. So we can get the associated employee IDs like this. So we could say, if we wanted it for a particular order ID, we could say select, let's go with order ID, and customer ID from, what table is this? Orders? So from orders, where the order ID is equal to 10248. Okay, so we've seen that before. There we go. We got the customer ID that we're interested in. Now, how do we merge that with all the customer information? Because it's in a different table. Well, this time we're going to do something called subquery, where basically this is going to be kind of a nested query, where here we're going to put this in brackets and we're going to say, actually, don't get the order ID as well, because I know that that's the associated order ID. I want to get the customer ID. So now that I have it basically in this list where it's saying a bunch of customer IDs, if I have this, it's not going to like it because I put it in brackets now. But what it basically is this thing. It's 90. And if we had multiple values, it'd be 90, 45, 20, whatever they are, to the IDs of interest. So if I did put this in brackets, you can then do this in thing, where I said select star from customers. So that's all of that customer information associated with what? Well, I have to say select star from customers where the customer ID, okay, so this is, remember, this is a column that's in the customers table. So where this customer ID is in this list. It's very similar to before. It's saying, get the rows where we're in this list. We'll get the rows where this column is in this list, except this list is a query. So it's a subquery. And then we get all that information according to that customer ID. And if instead we wanted for multiple order IDs, or for any other question we wanted to ask, we could say where order ID is in say, 10248, and maybe there's a 10249. I assume there would be. Didn't like that, and that's because I missed my other bracket. And after that, we have two entries. So it was customer 81 and 90. Here are their names, and the associated order ID is kind of lost because we didn't bring that over, and there's not really a good way to in subqueries that I'm aware of, but we can do this differently in a join, which I'll show you now. Here's how I'd write the exact same thing. I'll just stick with this order ID, but with a join, and they're a lot easier to write. So select star from customers. Again, let's just start from there so we know what we're looking at here. So I want to get the order ID. So actually I'll look at the orders table. And so I'm saying, okay, I want the employee information for this order ID. Well, I can say select star from customers. So I want all that customers data, except select star from customers join. Okay, join with what? With what table? I want to join customers with orders. Okay, so join orders on. So what is the way I'm joining them, or what is the column I'm joining them? Basically, I'm saying wherever the customer ID, sorry, this is the other table, so it's kind of confusing me, where the customers dot customer ID, and we're writing that because now it's not certain which column we're referring to by default, because now we have multiple tables. So I'm saying this is the table name dot customer ID. So where this, from the customers table, this customer ID, where that is equal to the orders dot order customer ID. Sorry. Okay. So where these ones match, where I have the customer ID is equal to the orders dot customer ID. So I match all of them. And now this is not the exact same thing as before. This is basically the matching of all of the two tables. So wherever we had a match between a customer ID in one table and a customer ID in the other table, then we're going to get those row combinations. So we may now have multiple customer ID here. So customer IDs here. So if I show you this ordered by, so ordered by customers dot customer ID, if I order that, you'll see I occasionally do have multiple customer IDs now, and that means that these customers made multiple orders. Okay, so here's a nice join. This is something you'll do very, very, very commonly, and with multiple, like more than two tables as well. But to do the exact same thing as before, well, now that we have this table, it's the same thing as basically one big table. So well, we can just do the same thing as before. We can just say, okay, where the order ID, we have this column now, where the orders dot order ID is equal to whatever we want. I'll pick the first one again. This is different first one now, but where it's the orders dot order ID is equal to 10308. And so the problem here is that we have the where after the order by. You'll start to do this a lot when you're writing SQL code, is you kind of put it in the wrong order. But here, if I was to put it here, where orders.order ID is equal to that, and then ordered by that, then here you go. We only get this specific order ID, and it's the exact same, at least I picked a different order ID, but it's the exact same thing as before, just with a join. And you'll probably do this a lot more commonly, because when you're doing multiple tables, and sometimes you need to connect 2, 3, 4, 5 tables together, then it's a lot easier just to write join with this, join with this. Before you go, I just want to show you a couple tricks that could really help you in interviews, just some kind of weird stuff that you don't always see that often, but it does come up in interviews every now and then. So select star from customer, starting with that. What we can do if we wanted to get rid of duplicates, say if I instead had select customer name from customers, well, they're all going to have probably different names. In fact, if I can prove this by if I select the count of customer name, then that says I have 91 of these things. But if I do distinct, this gets rid of all the duplicate rows. And so it is actually exactly the same thing. It didn't have any duplicates. But if instead I was looking at, let me just look at star for a moment here. So say city, we're going to for sure, actually country, we're only going to have a few different countries. If I want to see how many different countries we have, for example, well, I could say select distinct country from customers. And so that gives just the different countries, and I can get the number of them. I know it says it down here, but that doesn't always work. You would do select the count of the distinct country. And then we say, okay, we have 21 different countries. So distinct gets rid of the duplicates. And if you were to get rid of duplicates in multiple columns, you would have this as another column and whatever. I'm just writing another column here. It would get rid of duplicates if it had the exact same value. If you had two rows that had the same of the first column and the same second column. Okay, so that's one thing. Another one is the idea of different joins. So technically we are looking at an inner join, which means we only look at the matches. But there is left and right joins. There's also other ones. So if again, I just started with select star from customers, but I wanted to do a left join, which I'll just show you what it does. We can do select star from customers join orders on customers dot customer ID, and I know I'm kind of sloppy with the capitals, it doesn't matter. Customers dot customer ID is equal to orders dot order, customer ID. Okay, so that's the same inner join as before. When we get all of these matches, if I order it by, it's easy to see if I do order by customer ID, then we get, you can see there's duplicates here, except we want to keep those duplicates. What we want to do is instead, if I write left join, then I will show you that occasionally we get null values here and null values on the order table stuff. So this is all the customer table stuff. And so if we do a left join, so left is referring to this is the table on the left and this is the one on the right. So we're going to keep all of the rows on the left, except even if they match, like, so if they match or they don't match, meaning if for each of the customer IDs, if I find a corresponding one in the other table, then I would get the data there because it's a match and say, okay, I want to give you this data. Except if there actually wasn't a match, if we had in the customers table a customer ID of 1, except that wasn't in the other one, then you can see we're getting nulls here because it doesn't exist. So that's what a left join does, is sometimes you want this. I'm not sure why it's not giving the value of 1 rather than null, but it's saying that this value was null. We didn't get a match. Okay, so there's left join, and right join is pretty much the same thing, except it would do it for the other one. Thanks so much for watching. For additional practice, I'd look at LeetCode or some other platforms. I have some links in the description below if you want to do a specialization on SQL, and subscribe if you're not already, like the video. I'll see you in the next video.